What are the roles and responsibilities of a software developer? Do you want to become a software developer and are not sure about what a software developer does? What are all the things you must learn to make sure that you become a successful software developer? Then please watch this video carefully. We are going to discuss the roles and responsibilities of a software developer in detail. It will help you in preparation for job interviews. I am going to explain 14 main things that a software developer does regularly, and you must acquire all these skills when you are doing graduation or masters in computer science or information technology. A software developer's role involves various tasks and responsibilities related to designing, coding, testing, and maintaining software applications. Here are some of the key roles and responsibilities of a software developer.
Software design and architecture. Software design and architecture are critical phases in the software development process that involve planning and organizing the structure of a software system. They encompass decisions about how the software components will interact, what technologies and patterns will be used, and how the system will meet its functional and non-functional requirements.
Coding and implementation. Coding and implementation are crucial steps in the software development process where the software design is turned into executable instructions that a computer can understand and execute. This is the phase in which the software design comes to life, and it's where the developer's expertise and creativity play a crucial role in building functional and efficient software systems. Key aspects of coding and implementation include writing source code, translating design into code, testing and debugging, version control, integration, database setup, external integrations, performance considerations, security measures, documentation and comments, code reviews, and code refactoring.
Debugging and troubleshooting. Debugging and troubleshooting are critical activities in software development that involve identifying and resolving issues or errors in a software application. These tasks are essential for ensuring that the software functions correctly and meets its intended requirements. Let's understand debugging and troubleshooting one by one. Debugging. Debugging is the process of finding and fixing bugs or errors in a software program. It involves identifying the root cause of unexpected behavior, incorrect outputs, or system crashes and making the necessary corrections to the code. Troubleshooting. Troubleshooting is a broader term that encompasses the process of identifying, isolating, and resolving any kind of problem or issue in a system. While debugging specifically refers to resolving correlated issues, troubleshooting may involve broader system-level problems, including hardware, network, configuration, and more.
Version control and collaboration. Version control and collaboration are fundamental aspects of modern software development that enable teams to work together efficiently on a shared codebase. They help manage code changes, track revisions, and facilitate collaboration among team members. Version control. Version control, also known as source control or revision control, is a system that tracks and manages changes to files and code over time. It allows multiple developers to work on the same project simultaneously while keeping track of the changes made by each contributor. Collaboration. Collaboration in software development refers to the process of multiple team members working together on a shared project or codebase. It involves tasks like code review, discussing and planning features, and resolving issues. Effective collaboration improves productivity, code quality, and overall project success.
Software testing. Unit testing. Unit testing is a type of software testing in which individual units or components of a software application are tested in isolation. The purpose of unit testing is to validate that each unit of the software functions as intended and meets its design specifications. A unit in this context refers to the smallest testable part of a software, such as a function, method, or class. Key characteristics and aspects of unit testing include isolation of units, automated testing, granularity, fast execution, testing frameworks, assertions, mocking and stubbing, code coverage, regression testing, refactoring support, continuous integration, CI.
Documentation. Documentation in software development is crucial for ensuring the clarity, maintainability, and long-term success of a project. It serves as a comprehensive reference guide for developers, stakeholders, and future maintainers. Here are some key reasons why documentation is important. Clarity and understanding, onboarding and training, maintenance and updates, collaboration and communication, compliance and auditing, knowledge transfer, problem solving and troubleshooting, risk mitigation. Things that need to be documented in software development. Requirements and specifications, architecture and design, codebase overview, code comments, API documentation, installation and setup, user guides and manuals, testing documentation, release notes, dependencies and third-party components.
Performance optimization. Performance optimization in software development refers to the process of improving the speed, responsiveness, efficiency, and resource utilization of a software application. The goal of performance optimization is to ensure that the software meets its performance requirements and provides a smooth and responsive user experience. Performance optimization is a critical aspect of software development, especially for applications that require high levels of efficiency and responsiveness. It's an ongoing process that may involve iterative improvements as the software evolves and user requirements change. Key aspects of performance optimization include response time, throughput, resource utilization, scalability, optimizing algorithms and data structures, database optimization, code profiling, caching, concurrency and parallelism, network optimization, front-end optimization, load testing, code review and refactoring, minimizing resource leaks, and monitoring and profiling in production.
Security. Security plays a critical role in software development to protect sensitive information, ensure the integrity of systems, and safeguard against unauthorized access or malicious attacks. It encompasses various practices and measures implemented throughout the software development lifecycle to mitigate security risks. Security is an ongoing process that should be integrated into every phase of the software development lifecycle. It is essential for protecting sensitive data, maintaining user trust, and ensuring the long-term success of software applications. Here are key aspects of the role of security in software development. Confidentiality, integrity, availability, authentication, authorization, data encryption, input validation, secure coding practices, security testing, patch management, identity and access management, IAM, security policies and compliance, education and awareness, security documentation.
Continuous integration, continuous deployment, CI/CD. Continuous integration, continuous deployment, CI/CD, is a set of practices and principles used in software development to automate the process of integrating code changes, testing them, and deploying them to production or staging environments. CI/CD aims to streamline the development and deployment pipeline, enabling faster and more reliable software delivery. It is a fundamental practice in DevOps and agile development methodologies. It enables development teams to deliver high-quality software at a rapid pace, aligning with the demands of modern software development.
Adherence to coding standards. Adherence to coding standards contributes to the creation of more reliable, maintainable, and high-quality software. It fosters a disciplined and collaborative development environment, which is essential for successful software projects. Adherence to coding standards is crucial in software development for several important reasons. Readability and maintainability, consistency across the code base, reduced error rates, ease of code reviews, code reusability, easier onboarding for new team members, compliance with organizational policies, automated code analysis, improved collaboration, professionalism and code quality, and facilitates code reviews and pair programming.
Maintenance and updates. Maintenance and updates in software development refer to the ongoing activities involved in managing, enhancing, and ensuring the continued functionality, reliability, and performance of a software application after its initial development and deployment. These activities are essential for keeping the software relevant, secure, and effective over time. They help extend the life of the software, enhance its value to users, and ensure that it continues to meet evolving needs and requirements.
Collaboration with stakeholders. Collaboration with stakeholders in software development refers to the process of actively involving and engaging individuals or groups who have a vested interest in the success of the software project. Stakeholders can include clients, end users, business owners, project managers, quality assurance teams, designers, and other relevant parties. Effective collaboration ensures that the software meets the needs and expectations of all stakeholders and aligns with the overall goals of the project.
Research and learning. Research and continuous learning are essential for software developers due to the ever-evolving nature of technology and the fast-paced software development industry. They are integral to a developer's ability to stay competitive, produce high-quality software, and contribute effectively to the success of projects and organizations. It's a dynamic field, and being proactive in seeking out new knowledge and skills is a hallmark of a successful software developer.
Time management and prioritization. Time management and prioritization are crucial skills for a software developer due to the complex and deadline-driven nature of software development projects. These skills enable software developers to work efficiently, deliver high-quality software, meet project deadlines, and maintain a healthy work-life balance. These skills contribute significantly to the overall success and productivity of software development projects.
Thanks for watching. Please share, like, and subscribe.